This is one of the traditional glass-based sort of LED filament lamps, and it's very stylish. They seem to have taken the eBay by storm. And this is the new kid in the block. This is very odd and very interesting. Now, so this is supposedly 12 watt. And the arrangement inside, I'm going to have to unplug this because it's just so bright, and it really is bright, and it really spreads light around the room like a traditional sort of LED filament. And what's interesting about this is that this is just slotted through and through. It's completely ventilated, and it's translucent plastic, so it does light up, but also a lot of the light comes through the gaps, and it really is incredibly bright. It has a very even 360-degree wash around the room. It's very good. And looking through the top, you know what, we'll just take it to bits. That's the best bit, isn't it? I got this to explore and take to bits, and I'll probably burst it in the process. But so be it. Saves you guys having to break yours. I have got one of these spodgers now, thanks to someone who gave me I can't remember who it was, but they gave me a link to this one. This is kind of glued as well. Hopefully I'm not going to burst the connection off the cob. Not very easy to open, I have to say. Not very easy to open at all. I don't think it's glued, but it might be glued. But certainly where the filament assembly is inside, it is glued. Another odd thing about this, I left this on for a while, and really it's so well ventilated, it just, you know, hand temperature. Really absolutely no major heat at all. Even the base for the 6 watts it was running at didn't seem to get that hot. I may have to pause momentarily. Oh wait, nope, nope, hold on, I can see it kind of parting now. If it comes to, I'll just cut this thing open because, you know, I'm not too bothered. I think it's more interesting, you know, it's more important to see what's inside than maintain its structural integrity. Yeah, this is glued. I may end up having to cut this open. Oh, that is so well sealed. This is the point I start thinking, you know, maybe I should have paused if I'd known it was going to be like this, but having said that, sometimes they open quickly and sometimes they don't. That is really glued tight. Where's my... let's just rip it open. Lacks subtlety. I think it's better to actually keep the cob intact than the plastic top. Right, no, I'm losing patience now. Oh, that is thick glass by the look of it. Is it glass? Right, here's the cob. That's quite intriguing. That is thick glass. That glass is about 3mm, 1/8 of an inch thick. Glued at the corners. Okay. Now, I see they put a drop of glue. I don't know if that was purely to fix it or it's to act as insulation because it's quite close to edge as well. That's odd. There's also what almost looks like a little logo printed on here as well. This is very intriguing. I'm surprised at the thickness of the glass. I suppose it makes it much more stable. I'm guessing this is probably going to be about a voltage of about, let's get some more of this plastic out of the way. It's a shame, but you know what? It has to be done. Let's get the whole lot out of the way, in fact. This can just be one of those destructive moments. So let's plug this in and check the voltage across. I would guess it's probably going to be about 70 volts across each of these, as is so common with those filaments. So let's get the adapter. plug it in. That's kind of neat, isn't it? Just in its own right, that is so intense. And I'll get the meter. We'll stick it up to about 200 volts. I'm guessing 140 volts combined because it appears to be two in series twice and then those ones in parallel. So I'll just untangle the reeds here and we'll see what voltage we're getting. Oh, I'm not getting quite on. It's quite hard to make connection here. Oh, about 100 volts, so about 50 volts across each filament. That's interesting. Right, let's take a wee look at the driver then. Just looking at the arrangement here, the LEDs must be tiny, I just can't even see them at all in the back of the glass. That's odd. Unless they've taken standard filaments and stuck them. Actually, they're not physically mounted onto the glass. You'd have thought the glass would have been used as a substrate though. So surprised it's glass. Yep, tooth test, it's glass. Right, let's pop the driver out the base then and see what it's like. I'm guessing it might come out like this. Little tiny bit more force required. Is that glued in as well? I should actually check polarity and probably taken this thing off. I'll do that in fact. I'm just going to check polarity of this. So I'll power it up again, check polarity, mark the cables and then cut them because I kind of want to keep this. I quite like it. You know, I like the electronic module. So let's find what polarity it is. Maybe the mark, this little logo mark, is at the positive end. Helps if you turn the meter on. No, it's the negative end. Okay. Rightio. So I'm going to get a Sharpie here. And I'm going to put a wee dot in there, and a wee dot in there, and I'm going to cut those wires. Okie dokie. Right, let's get into this now. All I'm managing to do at the moment is pull these little bits of the casing off. This is glued, I think. Oh well, they're off now. Let's see if I can impale myself. It's well glued. I think it's glued. Oh god, that's so tight. Yeah, you know, I'm going to pause momentarily just in case this takes ages. Yeah, I'm glad I paused there. That was very messy indeed. I had to get the vice of enlightenment out here and really crush and prise into it and smash things with hammers. Well, hammers, I say hammers, I'm talking about snips, but you know, the sort of thing. But it's open now. And it reveals that the power supply inside is a little switchboard, but it's a buck regulator. And the number on the chip here, it's got the usual rectifier, it's got the smoothing capacitor, 4.7 microfarad, 400 volts, very common. The output one is 2.2 microfarad, 400 volts. And the chip is a MC5831, which, oh, hold on a second, I just printed that off, one moment. Here we go, quite hard to find. This is about the best I could find on the MC5831. It's a fairly typical arrangement and in the same listing I saw this, the same site I saw this image, it also had in Chinese the MC5831 and BP2831A. And the BP is a bright power chip, 2831A, and I looked up its data sheet and it's identical. So I don't know if this is just a rebadge or a clone, but it's pretty much a sort of bright power type chip where you set the current with a programming pin for the using a resistor. Yes, if it is that, then it's well within the range, because this was being run at approximately 100 volts, and for 6 watts of power that equates to about 60 milliamps, which seems a lot for these cob chips, particularly given you've got 2 sets in parallel, but it's 30 milliamp per chain. But I suppose, unlike the little thin filament cob ones like this one has a big slab of glass to dissipate into, so you know it's not going to get too hot. What did throw me a wee bit was the fact that I couldn't see the LEDs underneath, but latterly, if you actually look at this, it's kind of printed with a sort of sharp-edged sort of layer of phosphor underneath, and they must put the LED chips on top of that and then put the gel over the top of them. And since I think we need to go a little bit deeper into this, so I'm just going to pare a little bit of away with a knife, and it's a crime, but hey, you know, it's better me doing it to this one than you guys having to do it to yours, so let's peel some away. That's revealing nothing. I can hear it crunching through layers now. Right, let's take a closer look. Ah, that's slightly odd. Gonna have to go in a wee bit deeper. It's not just a row, it actually seems to be speckled backwards and forwards. Almost like a sort of checkerboardy type sort of arrangement. Oh, they're really coming off scrunchily now. I might be wrong. That might just be the... They do seem to be staggered, as in, you know what, I think there's 2 rows next to each other. Oh, there are. That's why that was that. I can see the wires at the end. I don't know if you guys are going to... Actually, you know what, let's try and... is this going to work? I can't really see this on the screen, so it's not necessarily going to really help all that much. No, I don't think that's going to work at all, is it? It was worth a go. What I'm seeing here... Where's my notepad? My notepad is nowhere to be seen right now. I'm really well planned right now. Here we go. What I'm seeing here is, instead of the usual arrangement you'd expect of just a row of chips like that, they seem to have them staggered. The first one row, and then the other one is staggered like that. And that's what's actually running in that layer. I might actually try and energise just one section up afterwards just to double check that, but that's what it looks like so far. And you can see the sort of wires jumping along like that, along them. So that will also be, that means they will be running about 15 milliamps per section, which is really common for these cobs. That's what they'd run these at. So the fact they've got 2 parallel circuits, and each of these strips would actually suggest they are running each section at 15 milliamps. So that is an interesting lamp. I've not seen them since. Can't even find them on eBay. They're just that completely radically new. It's just I wonder if they're going to make I wonder if they're going to establish themselves, because certainly the output from it was really, really impressive. So that's interesting. It's been very good. Yeah, that was definitely worth buying and taking to bits. Darn. I was hoping to actually test the other half of this section with that improvised power supply, but once I'd hooked up my improvised power supply, which is just straight off the mains, with 2 100k resistors and a diode in series, just very flickery, and it's halfway rectified. Then I found that I've actually cut into some of the leads for the LEDs in this section, but if I hold it precariously with my fingers, try not to get a shock in the process, because that would be quite tingly indeed, and I bridge it with a metal knife blade, I should be able to get... There's the inner circuit, which is very super flickery. Oh, I'm going to cop it shortly. I'm just not getting a good connection there, but then again I'm probing around with a knife onto LEDs and tiny little gold wires, so that's not really surprising. So anyway, there's an inner circuit there it is, which has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. It's got about 18 LEDs, and then it's got an outer circuit, again just matching the same, on the edge of the thing as well. So it is actually arranged as two long strings of LEDs. And let's see, that was about 18 plus 18. 18 times 2 equals 36 times round about 3 volts equals the 108 volts. That's what I was getting, so that's it. It's 2 strings of 36 on that side and 2 strings of 36 on that side to make up the full number of LEDs, so that's quite interesting. I shall put that down before I get a zap off it, and I shall disconnect it. See the resistors and the diode. Precarious, but hey, did the job. So yeah, interesting LED, really quite like that a lot.